Aviation has gone through 3 revolutions. The first revolution was brought by the ability to power and control flight, introduced by the Wright brothers at the turn of the 20th century. The second, the introduction of the jet engine. The first aircraft to run on turbojet power alone was the German Heinkel HE-178 in 1939. The third revolution was the democratization of flight as a means of travel. Commercial air travel was, initially, only affordable to the rich. The significant improvement in affordability was brought on by many factors, including the introduction of wide-body aircraft during the 70s, which enabled more economic travel. Perhaps a fourth revolution is on the horizon, with the transition to sustainable aviation. Civil aviation is approximated to be responsible for about 2 to 3% of all man-made greenhouse emissions. At the same time, the passenger demand is steadily increasing. Airbus has estimated that the global aircraft fleet will double by 2043. Consequently, there is a need to change energy sources to prevent further damage to the atmosphere. But revolutions don't come easy. For the past 6 decades, manufacturers have built up their confidence in designing and realizing commercial aircraft. Changes to aircraft systems design do happen, but usually slowly and incrementally. The B-47 bomber, introduced in 1951, is said to be one of the key inspirations for commercial aircraft design.
When considering its overall shape and form, it certainly shares similarities with contemporary passenger aircraft.
By iterating this concept, manufacturers have become increasingly confident in their designs. A common saying within the aviation industry is that a solution has been proven in flight, and that it therefore constitutes a reduced risk. Naturally, when manufacturers do what they do best, it reduces their economic risk. But it also helps maintain a high safety standard. Modern aircraft uphold an exceptional level of safety, and indeed, traveling by aircraft has never been safer. But while this conservative approach to design has obvious merit, it becomes an obstacle when the requirement changes drastically. Presently, the aviation industry has been challenged to drastically reduce its environmental impact. In Fly the Green Deal, a report detailing the sustainability targets for European aviation, it is stated as a long-term goal to achieve net zero carbon emissions by 2050. In addition, multiple other requirements are to be met, including an overall improved passenger experience and a reduction to aircraft noise around airports. How can aircraft systems manufacturers reach these targets without compromising on safety and without risking their own economic sustainability? At the same time, manufacturers are pressured into change to stay competitive. So, what alternatives are currently being considered? Electric aircraft can potentially result in zero emissions during operations. Making matters of sustainability more complicated, the manufacturing of batteries of appropriate capacity necessitates the unearthing and processing of critical elements, which can have negative societal and environmental consequences. From a performance perspective, modern battery technology is not sufficient to carry passengers safely over long distances. This limits the use to short regional flights, but even then the capacity is often insufficient. To overcome this issue, one idea is to pair the electric energy source with a gas turbine, creating a hybrid system that can potentially switch to combustion when necessary. Another option is to use hydrogen as a source of energy. Burning hydrogen enables many of the core technologies of contemporary aircraft engines to remain, thus reducing risk to that particularly sensitive part of aircraft systems. However, to supply the engines with hydrogen, large cryogenic fuel tanks are necessary to store the hydrogen at the appropriate temperature. The tanks need to be large, as hydrogen has significantly lower volumetric energy density relative to traditional kerosene. Both electricity and hydrogen-based aircraft have the drawback of requiring significant changes to current infrastructure. Electric aircraft will require improving the robustness of the electric grid, while hydrogen requires the development of logistics and storage systems to provide cooled hydrogen. A third option is to utilize synthetic fuels. Sustainable aviation fuels, or SAFs, are a particular class of fuel which is manufactured from, for instance, crops. These have the benefit of being drop-in, meaning that they can more or less be used in already existing aircraft with minimal modifications. However, SAFs are expensive, and growing the required crops demand large areas of land, potentially competing with food production. Furthermore, while SAFs could potentially result in net zero CO2 emissions, they still emit other greenhouse gases, such as nitrogen oxides. So, what will the future of aviation look like? Ideas such as turning to batteries or hydrogen are radically different from conventional solutions. Consequently, they entail significant risk. SAFs, on the other hand, enables manufacturers to maintain a lot of existing subsystems, but are not expected to solve the emissions problem, only ameliorate it. Perhaps the answer is that we as a society need to change our habits and significantly reduce our dependence on aircraft for travel and transportation of cargo. To conclude, the state of commercial aviation is unsustainable, but there are no obvious solutions.